I'm Margie Coleman. Today we're going to talk about factoring and the quadratic formula. In this lesson, we're going to solve quadratic equations by factoring and by using the quadratic formula. Since factoring is often the most efficient method, we'll start with that. Suppose we have the following quadratic equation. X squared plus 7x plus 12 equals 0. We want to factor the quadratic. In this case, we're thinking about using the FOIL method backward. So, we'll have two parentheses with a binomial in each so that multiplying them gives us the quadratic equation. We know the first term in each parentheses is x because their product has to be x squared. So we need two numbers, here and here, that have a product of 12 and a sum of 7. First, we'll list the factor pairs of 12. We could use 1 and 12, or 2 and 6, or 3 and 4. This pair has a sum of 7. So we have x plus 3 times x plus 4 equals 0. This is the factored form. Notice now we have two things multiplied together with a product of 0. Think about multiplying. What always has to be true when a product equals 0? One of the factors must be 0. So we'll write a statement that says essentially that. X plus 3 equals 0, or x plus 4 equals 0. Now we solve each part. Subtracting 3 from each side here, we get x equals negative 3. Subtracting 4 here, we get x equals negative 4. These are our solutions to our quadratic equation. Of course, we'll want to check our answers. We can substitute each value into the original equation one at a time. So we get negative 3 squared plus 7 times negative 3 plus 12. And we want to know, does that equal 0? Negative 3 squared is 9. 7 times negative 3 gives us minus 21 plus 12. 9 minus 21 is negative 12, plus 12 is 0. So negative 3 works. You can also plug in negative 4 in the same way, and you'll find that that also works. Let's try another example. 3x squared plus 9x minus 12 equals 0. Notice in this case, all three terms are divisible by 3. That means 3 is the greatest common factor for these terms. Whenever there's a greatest common factor other than 1, for the terms of our quadratic, we should start by factoring that out like this. We put the 3 out in front of a parentheses. Inside, we write all the terms we need so that distributing the 3 will give us the original quadratic. So 3 times x squared is 3x squared. 3 times plus 3x gives me the plus 9x. And 3 times minus 4 gives me the minus 12. So now we have this equation. Now we just factor the part inside the parentheses as we did in our last example. So we put our two parentheses here. We know that we're going to have an x at the beginning of each one to create the x squared. Now I need these two numbers to have a product of negative 4 and a sum of 3. Listing the factor pairs, we could have 1 and negative 4, or we could have negative 1 and positive 4. Either way, we get a negative 4 product. We also could have negative 2 and positive 2. Now we need to check the sums to find the one that adds up to 3. You'll notice this pair adds up to 3. So now we have 3 times x minus 1 times x plus 4 equals 0. Since 3 cannot equal 0, then we still have just two more factors that could be 0. So we're going to say either x minus 1 has to be 0 or x plus 4 has to be 0. Again, solving each one, we get that either x equals 1 or x equals negative 4. How about this one? 3x squared minus 6x equals 0. This time, our terms have a greatest common factor of 3x. So we'll factor that out. 3x times x gives me 3x squared, and 3x times minus 2 gives me minus 6x. We can go ahead and solve without any more factoring since we have two things with a product of 0. So we say 3x equals 0 or x minus 2 equals 0. Again, solving each one, if we divide both sides here by 3, we get that x is 0. Or over here, we add 2 to both sides, and we get x equals 2. Again, be sure that you check your solutions. Now let's try this one. 2x squared minus 5x minus 3 equals 0. There is no greatest common factor to pull out, so we'll go ahead with FOIL backwards. We put our two parentheses, but now you'll notice just an x and an x isn't going to work because that has to multiply up to 2x squared. So now we're going to need a 2x and an x. Now our two numbers need to have a product of negative 3, but one of them will be multiplied by 2x before we get the sum, which needs to be negative 5. So let's list all the possible factors. We could have negative 1 and 3, but we have to worry about the order that we put them in. This way, the 3 gets multiplied by 2x. It could be that we want the negative 1 to be multiplied by 2x, so we have to list them in both orders. Another possibility is 1 and negative 3, and again, we want to list those in both orders. So now we check the factored pairs in each order so we can check the sum with either factor getting multiplied by 2. So we're just going to check the outer and inner multiplications. The first combination, we would have 3 times 2x is 6x, and negative 1 times x is minus x. 6x minus x is positive 5x, and we want negative 5x. So we're not going to use this combination. The next combination, negative 1 times 2x is negative 2x. 3 times x is 3x. 3x and negative 2x is 1x. So that's not our sum. Let's try this combination. Negative 3 times 2x is negative 6x. 1 times x is x. Negative 6x plus x does give us negative 5x. So this is our choice. So now we have 2x plus 1 times x minus 3 equals 0. Again, we have two things multiplied together with a product of 0, so either the first one has to equal 0 or the second one has to equal 0, and we'll solve each one. Subtracting 1 from both sides, we get 2x equals negative 1. Dividing by 2, we get x equals negative 1/2. On this side, all we have to do is add 3, and we get x equals 3. Again, remember to check your solutions. But sometimes a quadratic cannot be factored over the rational numbers. In that case, there are other methods of solution. One of these is called the quadratic formula, which says, for any quadratic equation of the form ax squared plus bx plus c equals 0, where a, b, and c are just numbers, the value of x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. Be sure to copy this in your notes so that you can find it later. Let's try an example. X squared plus 3x minus 5 equals 0. A is the coefficient of x squared, so a equals 1. B is the coefficient of x, so b equals 3. C is the constant term. That's the number with no variable. So c equals negative 5. Now we plug these values for a, b, and c into the quadratic formula. So we have x equals the opposite of 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 5, all of that divided by 2 times 1. We want to start by doing the multiplication and the power inside the square root. So we have negative 3 plus or minus 3 squared is 9, minus 4 times 1 times negative 5 gives us plus 20, and then 2 times 1 is 2. So we have x is equal to negative 3 plus or minus the square root of 29 all over 2. The plus or minus sign in the middle means we actually do have two solutions. We have that x could be negative 3 plus the square root of 29 all over 2, or x could be negative 3 minus the square root of 29 all over 2. One nice thing about the quadratic formula is that it works for any quadratic equation, whether or not it can be easily factored. It is not usually as efficient as factoring, but it will always work. For example, let's look at one of our earlier examples that we solved by factoring. 2x squared minus 5x minus 3 equals 0. So a equals 2, b equals negative 5, and c equals negative 3. Putting those values into the quadratic formula, we get that x equals positive 5 plus or minus the square root of negative 5 squared minus 4 times 2 times negative 3. All of that's inside square root, and then the whole thing divided by 2 times 2. So x equals 5 plus or minus the square root of 25, and then minus 4 times 2 times negative 3 would be plus 24, and that's over 4. So we have x equals 5 plus or minus the square root of 49 all over 4. We'll move over here. We know the square root of 49 is just 7. So I have 5 plus or minus 7 all over 4. So let's find the two solutions. We could have 5 plus 7 over 4, which is 12 over 4, or 3, or we could have 5 minus 7 over 4, which is negative 2 over 4, or negative 1/2. You'll notice these are the same solutions we got when we used factoring. Consider this example. 8x squared minus 2x minus 45 equals 0. So a equals 8, b equals negative 2, and c equals negative 45. That gives us positive 2 plus or minus the square root of negative 2 squared minus 4 times 8 times negative 45 And all of that is in the square root, all over 2 times 8. So x equals 2 plus or minus 4 plus, and if you multiply negative 4 times 8 times negative 45, you get 1,440. And all of that is over 16. So x equals 2 plus or minus the square root of 1,444 all over 16. But the square root of 1,444 is just 38. So I have 2 plus 38 over 16, which is 40 over 16, and I can divide top and bottom by 8 and get 5 over 2, or I have 2 minus 38 over 16, which is negative 36 over 16, and I can divide top and bottom by 4 and get negative 9/4. Now Paul will show us how to apply some of our skills.
If we take the equation 4x squared plus 12x plus 9 equals 0, we now have a leading coefficient which is different than just 1, and we would say a is equal to 4, b is equal to 12, and c is equal to 9. If we put those values in the quadratic formula and simplify it out, it eventually becomes x is equal to minus 3 over 2. But we also could factor that equation. In this case, we could say that factors of 4 are 4 and 1, factors of 4 are also 2 and 2, and then factors of 9 are 9 and 1, and also 3 and 3. The question would be, how could I get a sum? Because our last term is plus. How can I get a sum of 12? Well, 2 and 3 and 2 and 3. So that's what we have below. The quantity 2x plus 3 times the quantity 2x plus 3 equals 0. And when we solve that equation out, we have x is equal to minus 3 over 2. The same equation, the same answer, two different ways of doing the problem. So you have to decide as a student which is the most efficient for the problem which is being written. If we took a problem such as a majorette tosses a baton into the air, the baton leaves the majorette's hand at 5 feet above the ground with an initial velocity of 40 feet per second. The majorette catches the baton at 4 feet as it falls. How long was the baton in the air? The equation in this case would be h equals negative 16t squared plus v sub 0 times t plus h sub 0. Plugging in the values from the prior statement, we would have 4 equals negative 16t squared plus 40t plus 5. In this case, we would like to set it equal to 0, and we would say, in this case, a was equal to minus 16, b is equal to 40, and c is equal to 1. We would put it in a quadratic formula, simplify it out, use our calculator to do that, and in this case, please make sure that the numerator is in a parentheses. In other words, if you punch this on a calculator, it needs to be parentheses minus 40 plus the square root of 1,664 parentheses. A second parentheses closes the numerator out, and then divided by the quantity 2 times a minus 16 or minus 32. We get two answers. You have to write the equation twice, but one of the answers really doesn't make sense. 2.52 seconds after she threw the baton into the air would make sense. Minus 0.02 seconds before she threw the baton into the air, because this is a quadratic equation, it's a parabola. That second answer is there, but it does not make sense in the equation. If we have an open box with a square base, as is in the figure, we would like to be constructed of 84 square inches of cardboard. Now remember, it has an open box. So the equation in this case would be S, meaning the surface area, is equal to x squared, which becomes the bottom of the box, plus 4xh, which are the four sides, and we're going to solve that particular equation. When we do that, we have 84 equals x squared plus 8x. Now, from that standpoint, we now have a value where we have an equation of 84 equals x squared plus 4x plus 2. Notice all the possibilities that I have if we factor this as far as factors of 84. I have 1 in 84, 2 in 42, 3 in 28, 4 in 21, 6 in 14, and 7 in 12. We could actually solve that equation out. In this case, to get those values, it might be easier to use a quadratic formula, because if we do, we would say A is equal to 1, B is equal to 8, C is equal to minus 84. If we put those values in, we end up with minus 8 plus or minus 20 all over 2. Again, that simplifies into minus 4 plus or minus 10. And again, minus 4 minus 10 would be a minus 14. That answer doesn't make sense because we cannot have a side of a box being, in this case, minus 14 inches. What you could do is see if you get that same answer by taking those factors, and you find out if you can get x is equal to 6.
Thank you, Paul. Today we talked about factoring and using the quadratic formula to solve quadratic equations.